Swayam Prabha. Digital India. Educated India.
Now, we are going to discuss the concept of this hierarchical fuzzy logic controller. So, in short, this is known as HFLC. So, let us try to understand the reason behind going for this particular the HFLC. Now, let me assume a very complex the real world problem, supposing that the problem related to say weather forecasting. Now, if you see the problem of weather forecasting, whether there will be a rain or not up to say 2 hours or 3 hours. So, that particular prediction depends on a large number of parameters. Now, supposing that I am going to use a fuzzy reasoning tool as an expert system just to predict whether there will be rain or not. Now, if you see that particular process, so it depends on a large number of input parameters and the output, that is a function of a large number of input parameters like your I 1, I 2 up to your say I n, say large number of parameters, say might be n equals to 30 or say it n could be equals to 40 and so on. Then how to predict and how to design and develop the knowledge base for this particular the fuzzy reasoning tool. Now, to design this type of the fuzzy reasoning tool, actually we are going to face a major difficulty, and difficulty in the sense that we will have a large number of rules. Now, here if you see, say if I consider like n number of input parameters, for example, say, so this is nothing but your fuzzy logic controller and it has got a number of inputs like your I 1, I 2, I 3 up to n, I n, and supposing that n is equals to 40 and supposing that I have got only one output. Now, what should be the number of rules and what is the maximum number of rules which I will have to design? Now, to represent each of these input parameters like I 1, I 2 up to say I n, supposing that I am using say small m number of linguistic terms. Now, if I use small m number of linguistic terms to represent each of the input variables like I 1, I 2 say I n, and if there are n such input parameters, then what should be the number of rules? Now, the maximum number of rules will be how much? So, that is nothing but your m multiplied by m multiplied by m, and we have got n such terms, because we have got small n number of input variables. For each input variable, I have got m small m linguistic terms, and this will give rise to your m raised to the power n, and this is actually will be a very high number. Now, let us just try to put some numerical value. Supposing that n is equals to your say 40. So, small n if I put that is equals to say 40, and supposing that I am considering the small m is equals to say 5. That means, I am using 5 linguistic terms to represent each of the variable. So, the total number of rules that will become your m raised to the power n, that is nothing but is your 5 raised to the power your 40. Now, this 5 raised to the power 40 will give rise to a very large number. So many such rules you will have to design and so many such rules you will have to consider while determining the output for a set of input parameters. So, it is bit difficult in terms of computation, and as the number of input variable increases and as the number of linguistic term used to represent each of the input variable increases. So, what will happen to the number of rules? The number of rules is going to increase like anything, and computationally it will become very complex. Now, let me summarize whatever I have discussed. Now, supposing that I am just going to handle a real world problem having a large number of input variables, and if I use say 4 or 5 linguistic terms to represent each of the input variables. So, we need a very large number of rules, and as the number of rules increases, the computational complexity of this fuzzy logic controller is going to increase. So, this is not desirable, and this particular problem is actually known as the curse of dimensionality. Now, if you see the literature, so people are using this particular term, that is curse of dimensionality. So, the fuzzy reasoning tool or fuzzy logic controller is suffering from this particular drawback, and that is nothing but the curse of dimensionality. Now, how to solve this particular problem? To solve this particular problem, the concept of your HFLC, that is your hierarchical fuzzy logic controller, has come into the picture. Now, let us try to understand the working principle of this particular say HFLC. Now, to understand the working principle of this particular HFLC, so I will have to concentrate on this particular the figure. Now, here actually what we do is, we have got say the same problem, like I have got small n number of input parameters and I have got only one output, and previously I was using only one fuzzy logic controller. So, I have got a large number of inputs here, say I 1 and this is say I n, and I have got one output. So, this is actually the conventional FLC. Now, to replace that, so what I am doing is, I am just going to use the concept of HFLC or your hierarchical, the fuzzy reasoning tool or fuzzy logic controller. Now, the structure wise it is very simple. So, what you do is, out of this your the n input variables. So, we try to find out which are the most important ones. Now, supposing that, so it is very hypothetical. So, I 1 is very important, that means I 1 is having some significant contributions towards the output. Similarly, I 2 is another very important say input variables. So, what we do is, so this I 1 and I 2, so these two input variables we consider for the first fuzzy logic system, and whatever output we are getting from the first fuzzy logic system, so that will be used as the input for the second fuzzy logic system, and another input is also coming from here, say I 3 is coming here, and these two inputs are entering to the second fuzzy logic system, and it will give rise to an output that is nothing but O 2, and this particular O 2 is going to enter the third fuzzy logic system FLS 3, and another input is coming, say I 4 is coming, and here I will be getting the output that is O 3, and the same process will be continued, and the last fuzzy logic system, that will be your. So, here O n minus 2 is going to enter as input, and the last input, that is I n, is also going to enter, and on the output side we will be getting O n minus 1, and that is nothing but the final output. Now, here actually what we do is, the conventional fuzzy logic controller, that is replaced by a number of simple fuzzy logic systems, and these fuzzy logic systems are put in the hierarchical fashion. So, might be in the series these particular things are put, and by doing that actually we are getting one advantage. Now, let us try to understand what type of advantage we are getting. Now, here if you see, say if we concentrate on the first fuzzy logic system. So, there are two inputs. Supposing that for I 1, say I am using m linguistic terms, to represent I 2. So, I am using say m linguistic terms. So, what should be the number of rules? The number of rules will be nothing but m square, m multiplied by m. Okay. And this particular so this fuzzy logic system is going to tackle only m square rule, and similarly how many such fuzzy logic system we have got? We have got n minus 1 small fuzzy logic system. So, what should be the total number of rules which we are going to consider? That is nothing but m square multiplied by your n minus 1. Now, you see the advantage of this particular your this HFLC. So, previously in the conventional fuzzy logic system, so we had the total number of rules like your total number of rules like your the total number of rules like your m raised to the power, say m raised to the power n, and now actually in place of that we have got m square multiplied by your n minus 1. So, in the conventional fuzzy logic controller we had this number of rules, that is m raised to the power n, and now in the HFLC. So, we have got only m square multiplied by your say n minus 1. Let me take a very simple example. Let me put some numerical value, we will understand. Like if I put say m equals to say 4, and if I consider say n equals to 10. So, in the conventional FLC we had the maximum number of rules like 4 raised to the power 10, which is a very heavy high number, and in place of that. So, here I am getting like your m square, that is nothing but 16 multiplied by n minus 1. So, that is nothing but is your 9, and this is equals to your 144. So, in place of 4 raised to the power 10. So, in place of 4 raised to the power 10. So, I am actually using only 144 rules. So, this is actually the advantage of using this HFLC, that is the hierarchical fuzzy logic controller. Now, to conclude, actually what you will have to do is, for a problem having a large number of input variables. So, we generally go for, so this is your the hierarchical fuzzy logic controller. Now, here so this is the merit, this is the advantage of using HFLC, but it has got one demerit also. Now, that particular demerit is actually as follows, like we may not get the actual level of accuracy which we get in the conventional FLC. So, we will be getting less accuracy in HFLC in comparison with that of your conventional FLC, but computationally it is faster, HFLC is faster compared to your conventional FLC. So, these are the relative merits and demerits of conventional FLC and HFLC. Now, we are going to concentrate on another thing, that is called your the sensitivity analysis of a fuzzy reasoning tool or fuzzy logic controller. Now, let us try to understand the meaning of the term sensitivity. So, by sensitivity actually what we mean is actually the change of output to the change in input. So, sensitivity S is nothing but the change in output to the change in input. That means, for unit change of input, what should be the amount of change in output, that is nothing but the sensitivity. So, supposing that I have got one FLC which is used to model a process having say two inputs I 1 and I 2. So, here I have got one FLC having two inputs say I 1 and I 2, and I have got only one output. Now, my aim should be how to find out the rate of change of output with respect to your this particular I 1 and the rate of change of output with respect to this your I 2. That means, if I make unit change in I 1, what will happen to the change in output, and if I make unit change in I 2, what will happen to the change in output. So, those things actually we are going to find out. Now, how to determine this? So, the change in output to change in input. So, what we do is, so we vary the input variables by different amounts. For example, say we increase by say 0.1%, then 1% and then 10%, and we try to notice what should be the corresponding change in the value of the output. Now, if I change the input by say 0.1%, 1% and 10%, and if I can find out what should be the change in output. So, I can find out the sensitivity of this particular the fuzzy reasoning tool. Now, this is a very crude way of doing. Now, mathematically also we can find out. So, this particular the sensitivity. Now, let me concentrate on a fuzzy logic controller, which is going to determine the output for two inputs like I 1 and I 2. So, output is a function of the two input parameters I 1 and I 2. Now, what we do is, we just change the input I 1 by a small amount, say delta I 1. So, what we do is, so we try to find out the change in output, that is your delta O, and that is nothing but f of I 1 plus delta I 1 comma I 2. So, the change in I 1 is nothing but this amount delta I 1. So, we try to find out f of I 1 plus delta I 1 comma I 2 minus f of I 1 comma I 2, and this is nothing but the change in output, that is your delta O, and that is equal to the partial derivative of f with respect to I 1 multiplied by the change in I 1, that is delta I 1. So, this is the way actually we can find out in fact the change in output using the mean value theorem. So, using the mean value theorem, so this we can write down and we can find out this. Now, supposing that, so this particular your partial derivative of f with respect to your I 1, supposing that its mod value is coming to be say equal to 1. So, if it is found to be equal to 1, so we can write down that your change in output is nothing but is your is greater than your change in input. That means, your if I change this particular the input by a small amount. So, I will be getting more change in this particular output. So, this I 1 is actually very significant. So, we can determine the sensitivity analysis. So, following this particular the method. Now, in place of I 1, so I can also carry out the sensitivity analysis for I 2, and if you carry out the sensitivity analysis for I 2 by following the same principle, I can also find out what should be the change in output corresponding to the unit change in your input, that is your I 2. So, sensitivity analysis can be carried out both for I 1 and I 2 separately by following the same procedure which I have already discussed. Now, this is actually what we mean by the sensitivity analysis of the fuzzy reasoning tool, and we can find out the contribution of the different input parameters or the input variables towards its output, and we can find out the sensitivity analysis. Now, I am just going to discuss the merits and demerits of this fuzzy reasoning tool or fuzzy logic controller. The first point which I am going to make here, that fuzzy reasoning tool is a potential tool for dealing with imprecision and uncertainty. So, this I have already discussed several times. The second merit or the advantage of FLC, it does not require an extensive mathematical formulation. That means, if you want to find out the input output relationship, we need not go for the differential equation and its solution, and if the designer has some information of the process to be controlled or the process to be modeled. So, he or she can design the rule base, the database, that is nothing but the knowledge base of the fuzzy logic controller, and once that particular knowledge base has been determined, now if we just send one set of input parameters, there is a possibility. So, you will be getting the output. So, it does not require the extensive mathematical formulation of the problem, and one fact we have already discussed several times, that most of the real world problems are very complex and those are bit difficult to model mathematically, and that is why. So, this type of fuzzy reasoning tool or fuzzy logic controller is going to help us a lot, particularly for tackling or solving the complex real world problems. Now, I am just going to concentrate on the demerits. So, here to discuss the demerits, actually what I do is, so we try to say that the performance depends on the knowledge base and how to determine. So, this particular the optimal knowledge base, that means how to determine the database, how to determine the optimal rule base. So, that is a difficult task, and so the fuzzy reasoning tool in fact does not know anything, it does not have any inbuilt optimization tool. So, what you will have to do is, so you will have to optimize or you will have to train this fuzzy reasoning tool with the help of one optimizer and the known input output data. That means, we will have to design and develop the knowledge base of this particular the fuzzy logic controller or fuzzy reasoning tool. And as I told, determining the proper knowledge base is not an easy task, and in fact, we will be discussing like how to design and develop the optimal knowledge base of a fuzzy reasoning tool or a fuzzy logic controller, so that it can perform in the optimal sense. Now, the next point may not be suitable for modeling a process involving many variables. This problem we have already discussed. Like if there are large number of variables, like the problem of weather forecasting and so on, it is a very difficult problem, real world problem, and for this particular problem there will be a very large number of the input parameters or the input variables, and consequently the number of rules is going to increase like anything, and the computational complexity is going to be very heavy, and that is why for a problem having a large number of input parameters or the input variables. So, our recommendation should be, we should not go for this type of fuzzy reasoning tool or the fuzzy logic controller. And to solve this type of problem or to tackle this type of real world problem, in fact, we have got another very powerful tool, that is your artificial neural networks. So, those tools and techniques we will be discussing in details after some time. Thank you.